Hello friends, my name is Vivek Sharma. Today we can cover this interesting problem that's called the Maze. So Maze is a physical gaming device where we can play the game where we need to hit the target inside that device. So let's imagine like this kind of a container or like the physical any plastic or metal device that's having this rolling ball, and this ball will freely move here up, down, left, right based on the direction that you move this device itself. And this ball will not stop until it will hit the wall. It will hit the wall, right? So these are all the wall, like the gray area, these are all the wall, right? So this ball should hit the wall and then it will stop, and then basically it can again go to any of the directions, any of the four direction, up up, down, left, right, any direction. And if it is able to hit this target, that is the star here, then we would say okay, this is the true case, means our game is successfully completed. And if it is not able to hit this target, then we will say we cannot complete this game, and then we will return false. So this is the part of the problem. So in this particular case, this example 2, it will not be able to hit the target. And why it will not hit the target? Because if you see here, this ball will come, go through this target, but it will just hit the ball below the target itself, right? But it should stop to the target. So in the first example, it will stop to the target because it will hit the wall itself. So the ball will hit the wall in the target, and then we will say it's true, means it succeeded. So it, because it reached this target. So now let's see, and let's try to read the important points mentioned in this problem itself. So this is the same thing, like there is a ball and then in a maze with empty space. The important point here is the 0 is the empty space and 1 is the wall, right? So when the ball stops, and it will uh, ball can go through the empty spaces by rolling up, down, left or right. It would not stop rolling until hitting a wall. When the ball stops, it could choose the next direction. Alright, so given the ball's start position, the destination and the maze determine whether the ball could stop at the destination or not. So that's what we need to figure it out. Or actually we need to determine. So we would return either true or false. So here 1 means the wall, and then 0 means the empty space. I apologize because uh, I'm mixing the pronunciation here between the ball and wall. So 1 means the wall and 0 means the empty space. You may assume that the borders of the maze are all walls. The start and destination coordinates are represented by row and column indexes, of course, right? So let's try to understand it. I copied this screenshot here on the whiteboard, and then let's try to understand that how this game is going to work here. So let's see, this is the ball, right? So this circle, you can see the ball, and let's follow the rule that already uh, those rules have already been provided in the problem statement itself. So let's see, this ball will hit this wall, right? And now this ball will come here. Let's see, for example, right? Now this ball itself will have, can choose any of the four directions. Either it can go up or down or left or right. So let's consider that it choose the up direction. So it can go up again, right? And then it will come here and it will hit to this upper wall. And then let's say it chooses this left direction, then it will hit this wall itself. Then it can choose any other direction, left, right, up or down. Let's say it chooses the down direction, then it hit this wall. And let's say it chooses this right direction and it hits this wall. So the important point here to remember is this ball will not stop until it hits the wall, right? So let's say it hits this wall, and then let's say it can go down as well. Other option is it can go up, and it really depends the player of the game where it's rolling the ball, right? Rolling the ball, right? It Wherever it will turn that physical device, the ball will roll over in the same direction. It can roll in any direction. So don't apply the gravity here. Gravity means don't apply that it will always go down. It's not the case here in this case, because the problem statement itself says whenever the ball will hit the wall, then it can go in any direction. Either it can go up, down, or left or right, right? So let's consider, for example, it hits this down wall, and then now it will again will have the choice. It can go to the any direction, and we don't know that player will I mean the player, what the player is going to do, right? Here our intention is only to figure it out whether this given ball can hit the target or not. So let's say if it hits this wall, and once it hits this wall, then it will again have the choice go to any direction, up, down, left, or right. So it can again go to up direction as well, and it's perfectly fine, because as we mentioned that there can be any of the four direction. But in this case, if the ball is here, then it will just have basically up and the right side and the down, because uh, in fact this is the left side, up and down. Because the right side is basically blocked from the wall itself. So let's say it goes up, and then let's say it's again having the four direction. It can go any four direction, but for the simplicity, let's say it again hits this wall on the downside. And if the wall is here, then it will again have the choice. It can go to any other direction, any up, down, left, or right, whichever is available, or it can go to one by one all the directions available. So let's say it hits again the left side wall, and then let's say ball will come here, let's say, and then again it is having the choice. So up is blocked, down is blocked, left is blocked, only right side is available. So let's say it hits this wall. Once it hits this wall, it already reached to the target. So we will say okay, then we will just go ahead and return true. So I'm just trying to explore all the possibility that how the ball can hit. It can go to the, so here are the key observations that we have to consider while solving this problem, and those observations will help us to come up with the algorithm part, right? So one observation is, first of all, this ball can go to any direction, up, down, left, right. This is first observation after hitting the ball only, right? So if ball is hitting the wall, then only it can go to the any direction, up, down, left, and right. Second observation is ball will not stop until it hits the wall, right? So it will not stop until it hits the ball, until it hits the wall, right? So if it does not hit the wall, then it's not going to stop. It will keep rolling. And once it stops, then we need to choose any next four direction. So these are the key two observation, and if we are able to figure it out, these key two observation, then we can think of our approach, like how we are going to work and all, right? So let me do Control Z real quick, and let's try to be little bit realistic, and let's try to be little bit simpler here. So let's think about the ideal case. Let's say this is the ball and this is the given target, and let's say all these directions we have been given, right? So one case it can be, let's say it hits this left side wall, so it will go to the left side. Then what is the next? Then let's say it hits this downside, then left, down. Then after down, let's say it again hit this left wall, so again left. Then let's say it again hits this down wall, right? Not due to the gravity, but this is the one option. So don't think about that this is the only down. It can go to up as well, and it can hit again to the right side as well. It can go to any direction, right? let's say it went down, this is the one option, and then let's say it again hits right side, so right, and then after right, let's say it again hits the downside, so I will mention here the D, and then let's say it again hits the right side. So this is one sequence of the directions it may follow, and then it may hit the target. This is just a one observation and just a one sequence of the direction, but again there might be different set of the direction as well, because this is just one possibility, right? And with this possibility of directions we will be hitting this target. Other possibility, if I do the control Z here just real quick, and let's say, oops, let's say other possibility here is, let's say it again hits this down, so let's say down, then after down there is no other option, right? So again it needs to hit up, so it will be U up, then let's say it again hits left, then it's L, then it may again hit down, then down, and after down it may again go to, let's say, right, sorry, left, and then this is L, and after left it's willing to go to up direction, it may go to any direction, right? So up, and then after hitting the wall on the upper side, then let's say it again went down, then it may be down, and then it may hit again the right side, right? However, it can go multiple times to the up down as well, right? So it really depends upon the player, like how he's playing with that device, right? Let's say it hits the right side, and then after hitting right, then let's say player is not experienced, and then it's moving the ball on the upper side, and it may happen, right? Because it might need some pace from that device, and then it's just moving to the upside because it will give some pace, and then it will reflect immediately to the downside. That may be the reason that it's hitting the up, and that may be one possibility. And let's say the next direction he chooses or she chooses to the downside, so it's a down, and then again because the target is here, let's say he chooses or player chooses to the right side, so it is R. So this is also the one valid sequence of direction that may happen, right? So down and then up and then left, down, blah blah blah, right? So here the intention is just to explain that it may be the any direction. All right, so uh, let me undo all this thing. So now to solve this problem, there are two important points, key observations here is, one, that ball will not stop until it is going to hit the wall, and second is after hitting the ball then it can go to the any direction. So if we think about the first approach, like the ball will not stop, right? Or let me go ahead and write here itself because it's more text friendly. So first observation is ball will not stop. So how we can determine this, how we can implement this approach in the algorithmic way? If ball is not going to stop, then what I need to do in some while loop or something, I just need to keep rolling the ball until I hit the ball, right? So this is like, I can say depth first search. This pattern is depth first search. Why it's depth first search? Because it will just go deep till it does not hit the wall, right? So it is, I would say, DFS. After hitting the wall, uh, then after hitting the ball can go to any direction, any of four directions, right? So what is this pattern? That's called the breadth first search. Why I say the breadth first search? Because after hitting the wall, I will choose any arbitrary direction. When I say any direction means I will choose first left or right or down or right. I would like to explore all the four directions, right? And then I again will apply this depth first search. I will again hit the wall, and then I will again choose my next direction that I did not explore it earlier. right? I mean, because we don't know the player, we have to explore all the four directions here, because we are not the player, we are the software developer and we are just developing the software. So we have to explore all the four possibility of the all four directions, considering the player can hit any direction. So that's why we will go each and every of the four directions if it is not blocker. Blocker means if it is not the wall. So if it is not the wall, then basically we will explore all those directions here. So considering these two key observations, we can write the code quickly. So one is the DFS and another is the BFS. So what we will do, we will implement this algorithm, and then let's go ahead and create couple of placeholders, and then we will come back and then we will verify our assumptions here. All right, so let's think about that. We have to start with the start position. So what we will do, we will just move one direction by one direction. So what we will do, we will create the wrapper of breadth first search, and inside breadth first search we will try to roll this ball in the depth first search manner, right? We will just keep rolling until it's not hitting the ball, right? Until it's not hitting the wall, right? So that's what we will do. So let's go ahead and quickly do that. So for the BFS, what I would do, I would create the queue, and this is like just the general breadth first search algorithm. So why I'm taking here the integer array, because I would like to store my coordinates in the form of x and y in the queue, so that I would verify whether my start coordinates, if it is equals to destination coordinates, then that is the success criteria and I would return true in that case, right? Because I reached the destination. If I did not reach to the destination, then I would return false. So for example, in this case, right? In fact, I did not explain this case, but this is like uh, oops, this is self-explanatory, but let's go ahead and quickly check this as well, right? So let's say this is the ball here, right? And the ball, and then if it goes to left, for example, and then it hits the down wall, and then let's say it's again hits the left side wall, and then let's say it again hits the right downside wall, and then let's say it hits again the right side wall, and then again let's say it went to the downside downside direction, then it will hit the downside wall, but it will not reach to the destination. It will go through the destination, but there is no way that it will stop, because one key observation is ball is not going to stop, is never going to stop until it hits the wall, right? So there is no wall in the target, so it's the failure case. So this is the classical example of the failed case. All right, so in queue dot offer, we would what we would do, we would store first of the start position, because that's the our starting position of the rolling ball. And then what we would do, we will just check if our queue is not empty. Then what we will do, let's go ahead and pop all these current coordinates, right? So queue dot poll, and then let's check if it is current 0, if it is equals to destination 0, and this current coordinates y coordinates means 1 if it is equals to destination 1. If it is the case, then go ahead and return true. And for example, if this is not the case, then what we are going to do, we will just move all the four directions, right? So that's what we need to do. So let's go ahead and create the four directions. So let's go ahead and use this two-dimensional array, and all these four direction is 0 1. So what does that mean? 0 is origin and 1 is like the by coordinates, right? So if I have to explain it here, then let's say this is 0, this is 1, this is -1, and this is +1 here, and this is +1. So 0 is the origin, right? So this point is 0, right? So it will go either, in fact I have to, oops, so, so if I will choose the origin with the red color, this is the origin in the middle point, right? And so all the coordinates will be 0 to up, 0 1, 0 minus, 0 minus 1, this will be -1 actually, and this will be +1, 0 and -1 0 or +1 0, right? So x by coordinates. Okay, so that's what going to do here, and similarly 1 0 and -1 0. All right, so once we decide all these directions, what we are going to do, we will go each direction. So we will hit each direction, and we will just keep rolling the ball until it hits the wall, right? So to do that, we need to have some visited as well, because we don't want to explore the same direction again and again. So what we can do, we can just take some boolean array, two-dimensional array, and let's take the visited. So new boolean, and let's say this is maze. So maze dot length, and column is, let's say, maze 0 dot length. So this is the row length and this is the column length. All right, so this is one thing, and then we state, let's start 0, and start 1 we already inserted in our queue. So what we would do, we will just mark it as a true, because we are assuming that because it's already there in the queue, so we marking it as a visited because of the start position. So what we will do in this directions, all right, so here let's see this current 0 and hold this pi coordinates as a current 1, right? And in the while loop we need to keep rolling that ball, right? And let's check the valid, right? Valid means it will just make sure that whether it's valid or not. If it is valid, then what we will do, we will just keep going to that same direction again and again, right? So let's say our valid method is, hypothetically it's returning that it's the valid direction, or the it's not the wall, right? Then in that case what we will go, we will do x plus direction 0, and this is in fact single dimensional array, because we are iterating to the two-dimensional array, and two-dimensional array will give every time the one-dimensional array, because two-dimensional array is the collection of all the one-dimensional arrays. So every one-dimensional array we are just taking x and y coordinates here, and this y plus equals to direction 1. So this is the y coordinate. So we will just keep doing the same thing again and again. Okay, now this is the time, let's go ahead and check if our visited, so if our visited boolean array, if it should not be visited, right? If it is not visited, then go ahead and just add to the visited array, so that just make sure that we are not visiting it again that direction. And another thing is what we can do, we can just insert in our queue itself, right? So new int, because it's coordinates x and y, so let's go ahead and insert it in our queue as well. So this is what we need to do, and this is still queue is not empty, we have to explore all the 4 directions, right? And let's say we could not find such case, then we will go ahead and return false. Now let's go ahead and create a valid method. So boolean, let's say, is valid, and in it is valid, let's say what I need to do, I will get x and y coordinates, I can get maze as well, and the use of maze is I can just check whether it's a wall or not, right? So go ahead and return if x is greater than equals to 0, right? And if x is maze dot length and y is greater than equals to 0, so these directions should be valid, right? That's why we need to check all these things. So maze 0 dot length and this maze x and y coordinates, that should not be the wall, right? So not equals to 1. All right, if this is the case, then go ahead and return. This will be the valid. If any of these conditions is failing, then this is not the valid and we are not moving forward with the direction. Now here the important point is basically we need to pass this direction 0. Why we are already checking this? Because in advance we need to check whether in front of the ball, if there is any blocker wall or not, right? If there is a wall, then we will not increment inside the while loop, right? That's why we will be passing in advance, just to make sure that we don't hit any wall, right, while incrementing. If there is any wall and it's danger, it's blocker, then we are not going to hit that ball in that particular direction. So that's why we will just in advance we will be passing x plus direction 0 and similarly y plus direction 1, and we will be passing the maze itself. So this is like basic structure. This is how we can try to solve this problem, right? So basic structure is just go each individual after basically just go so first of all, first observation was ball will not stop. So this is kind of the DFS in the while loop if we can think of. But even with the while loop, basically we need to wrap inside the breadth first. So what we will do, we will go step by step, means one step in every direction, right? And we will just using the visited here. So just to make sure that we are not visiting the same direction again and again. So we are just visiting the one direction at one time. So the coordinates we are just making it as a true in the Boolean array, and then we are just in the queue itself we are maintaining those coordinates, and then again we are polling inside this outer while loop, and then again we are doing the same thing. If we reaches the destination, if we reach the destination, then it's the success case. Let's quickly check for the compilation error here, because I just blindly wrote all this code. So okay, so surprisingly this um, there is no compilation error this time. That's good. So let's go ahead and see, check, um, change the test case and just verify. So start coordinates is correct, and let's see if my target coordinates is 3 and 2 in the example 2, and let's see what's the result. So it's returning false, means these, at least these basic test cases are getting passed, right? Once I will hit submit, it will just run bunch of edge cases, all the cases as well that I'm not going to manually cover here, but it will run in the background, and then we will see whether it's going to submit or not. But hopefully the basic idea is clear, and let's quickly check what it's. So yeah, I mean, yeah, the approach is correct and it's working as expected. So hopefully this is clear, but again, couple of takeaways before ending this video is one thing is to understand this problem is just to imagine as a gaming device, and that's having the rolling ball inside that device, and that ball can roll in any 4 direction. That's first step, right? And this ball will not stop until it hits the wall in real, right? So once this observation comes in the mind that it's not going to stop, then definitely it's a depth first traversal. So that's the one observation. Another observation is, now let's say it stops at the wall. Now we need to choose any other 4 direction, right? So it will go one step at one time. It cannot go recursively, or it cannot go indefinitely until it hits the wall, because we already covered that scenario. So once we choose any of the 4 direction, then definitely we have to go step by step. So breadth first is more appropriate term for that kind of scenario. So it's a great blend of breadth first search plus depth first search, I would say. And that's why we are wrapping our this DFS thing in the breadth first. So we are going one direction at one time, and in the while loop we are just checking, okay, if it is the correct direction or if it is not a blocker, then just keep rolling that ball in the same direction again, and if it hits the wall, then basically just go ahead and store that direction in the visited array and just store in our queue itself. And then again from that point, let's hit again the, let's keep rolling that wall again in the while direction, and let's see what's going to happen next. So all the eligible wall coordinates we are recording basically in the visited array, right? So we are not going to record each and uh, every coordinate, and it does not make sense. We want to record whenever it hits the wall, and that's what exactly we are doing, because that's the eligible of the hitting the target. Because in this case, let's say in the example 2, if we see the example 2 here, this this target itself is not on the boundary, or if it is not on the wall itself, right? So it does not make sense to record these coordinates here. So hopefully this is useful, and thanks a lot for your time. Have a good one. Bye.